Hello everyone, this is Ganesh, and as part of today's, this week's assignment, I'm gonna do an analysis on Titanic dataset, which is one of the four datasets given by the professor. And for this analysis, I'm gonna propose three hypotheses, which I'm gonna uh, talk about in few minutes. So before that, let's see what are the variables in the data set. So first is a passenger ID. It is unique for each passengers. So it's not much of an use in this analysis. And a passenger class, there are three types of passenger class. The first class, that's for light people. The second class for mid-level economy people, and the class for lower economy people. So as the passengers of first class has to pay higher price compared to other two classes, and as the class goes on, the price decreases, as well as the luxuries and the facilities they uh, provide decreases as well. So keep in mind. And the sex zero, which denotes to male, and one which denotes to female here. Age of the passengers, sibling or spouse they traveled with in the ship, which is like, say for example, uh, passenger number 17, he traveled with four of his sibling or spouse, which means like he might have traveled with four siblings, or three siblings and a spouse, or it's something like that. And the survival rate, so zero means they unfortunately not survived, and one means they have survived. So for the purpose of this analysis, for the purpose of my hypothesis, I'm gonna correlate each one of these variables in B, C, D with F, which is passenger class versus survived, sex versus survived, age versus survived. So let me explain my hypothesis here. So my first hypothesis is the survival rate of passengers does not depend on their class of travel, which is the null hypothesis. And my alternate hypothesis is survival rate of passengers increased according to their class of travel, which means if they travel in first class, uh, they've been given the most priority. So in case of an emergency, they've been given the most priority to do all kinds of facilities to save their life. And it decreases as the class of travel increases from one to three. The facilities, the priority given to the passenger decreases. So I'm proposing that this is there in the data. So that is my first hypothesis. My second hypothesis is survival rate of passenger does not depend on their age, which is my null hypothesis. And my alternate hypothesis is survival rate of passenger increased as their age decreases. So as the passengers were older, the rate of survival is less. So the younger passengers, they tend to survive more on the, on the uh, sinking of the ship. So the next hypothesis is the survival rate of passengers does not depend on the sex, so whether they are male or female. Um, that is what I meant. And my alternate hypothesis is the survival of rate of passengers is more for female compared to male. So we're gonna check all these three hypotheses. We're gonna determine whether there is enough proof that my alternate hypothesis or can be true. So let's look at the descriptive statistics. Since most of them are bichotomous or trichotomous responses, as you mean, they just have they just have two or three options. So there's really not much significance to talk about when it comes to mean. But we can tell more stories about median and mode here. As we can see, the passenger class, you know, three mode and three median, which clearly means that there are more economical class, the lower economy class passengers that traveled in the ship. These people are more in numbers. Um, Compared to the other two classes. And when it comes to sex, we can see female, they travel more than males in the ship. and sorry, I mean, males, extremely sorry, like zero means male. So males, they travel more when compared to females in the ship. And age, so the median, mean, and mode, they kind of have a symmetrical distribution. So you can see that 30 on an average is the age of you know the passengers travel on the ship. And the like when we see the survival rate, most people did not make it, because zero, which means they did not survive. So most people did not make it, and that's all about the descriptive statistics. Since most responses are dichotomous and trichotomous responses, and when we see about uh, the regression analysis, the linear regression analysis with the sixth type as a survived, we can see that I told you earlier that zero is male and one is female. We can see that the survival rate is more for female when compared to male. So there is evidence, and you can see the significance is at 95% is very much lower than zero point zero 0.05. So we can say that there is a statistical significance in this analysis, which may provide enough sufficient evidence to prove that females had more survival rate than male. And the R square value, the correlation value is 0.295, which is not um, much correlated. You can say like um, it is near to zero than one. But since the number of values in the data is very less, I mean the number of responses is just they have just two options, like they have either male or female, and survival is like whether they survived or not survived. So there's just like four data points all these passengers can lay on. So we cannot do much about the Oscar value here when it comes to this data set. But we can say that the survival rate uh, kind of increased uh, compared to, I mean, for females compared to males. So that is one. And the other one is uh, the passenger class. Did they make any effect on the survival rate? Of course, it seems like it did make. First of all, it is statistically significant since it's less than zero point zero 0.05. And as you can see, the survival rate kind of increased as the passenger class uh, decreased, which means like for passenger class one, the class where the elite people travel on, they had more chance of survival. They survived the most, actually. They survived the most compared to other two classes. So the priority when it comes to the emergency board, the safety boards were given to first class passenger, and then to second class passenger, and finally to third class passenger. And the data proves that uh, I mean, it provides sufficient evidence, at least, that the first class passenger survival rate was more compared to other two class of passengers. And when it comes to the age versus um, the survival rate, we can see the survival rate is still two. I mean, it can either lay in one or zero. I mean, not survived or survived. But as you can see, there are like people of different ages. So as you can see this line, we can see that the survival rate was more when the age of passengers were less, and the survival rate was very less when the passenger's age was more. So it means the people who are aged less were given more priority. They were given more priority to save their lives compared to people who are older. So from this, what I'm trying to say is um, like I kind of remembered a saying when a ship sank, like people say, women's first and children's first. So I kind of believe that may be a fact that more number of women and more number of children are saved in this disaster. So that kind of um, matches relevance with this data here, and built a model on smart PLS. And yeah, as you can see here, so the same model, I've correlated passenger class with survival rate, sex with survival rate, and age with survival rate. The combined correlation is 0.423, which is kind of in the middle between 0 and 1, which is a decent amount of correlation, not good or not bad. And as you can see, sex compared to all the other values have more correlation. But remember, since the smart PLS only has a student license, the first 100 was taken out of all the population of 891. So a sample of 100, a convenience sample, let's say the first 100 was taken. So this value may not actually reflect the population, but due to our convenience, due to the restrictions we have using this smart PLS software, we kind of took the first 100. But let's see what we got about other. Uh, so as we mentioned, we got the survival. The R-square values here. So there is a negative correlation when it comes to age and passenger class, and a positive correlation when it comes to sex. And you see the R-square value is in the middle, and so the important thing here is the collinearity. So collinearity means whether um, the sex of a passenger or passenger class or age, which actually can be the cause for the survival rate. So how much collinear is that? So whether it's a positive collinearity, which indicates that it's actually true that as age increases, the survival decreases, as sex turns into a female. I mean, when it's a female passenger that survive more, or the passenger class when it's first class they survive more, actually kind of correlates with the survival rate we got in the data. So if it's positive, it is a positive correlation, and it kind of supports our hypothesis with a strong evidence. And if it's negative, it means maybe they are not relevant to each other. So when we looked at the inner model here, you can see all of them have a positive correlation effect, sorry, a positive collinearity effect. So they are collinear to survival rate, which provides a strong evidence that all of our hypotheses may be true. And that's all I wanted to convey from this data set. So when it comes to, let's recap the hypothesis again. So as you can see, we have strong evidences that the survival rate of passenger increased according to the class of travel. So the class of travel, when they travel in high class, the first class, they survive more compared to the person traveled in the third class. And as their age decreases, the survival rate increase, which means the children and the people who are uh, less aged uh, tended to survive more in this disaster. And when it comes to respect, we can see that the female compared to male survived more. So we kind of provided sufficient evidence with this data to kind of indicate our alternative hypothesis are kind of true. So thank you all for listening to this, and please leave your comments. Thank you.